Today, we need to talk about a couple of important ideas. The one is the Cartesian plane. Who would like to tell me about what goes on the Cartesian plane? You can put this in the chat, or you can raise your hand and I can hear your lovely voice. What is the Cartesian plane? It sounds like something from, I don't know, a faraway land. Well, it's sometimes called something else, but it's important for this topic. Who has any ideas? What's the Cartesian plane? What goes on it? What are some of the labels we might talk about? Pop your hand up if you can give us a little bit of a comment, or yeah, let's go to Khugotso. What do you know about the Cartesian plane?
I think the Cartesian plane shows us about the different quadrants and what's happening in those quadrants, according to my understanding.
Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Absolutely. Anything else that comes to mind?
The first quadrant, all the, what do you call them again? All positive. In the second quadrant, sine is only positive. Third, tangent is only positive. And
you know about the cast diagram. You know about the cast diagram. Okay, so I'm going to stop you there on the trig, because we're not going to be doing trig in this section, but that was great in terms of the Cartesian plane. Thank you so much. So I see that Sakile has said, what about the X and Y axis? So I just want to point that out to you. And then there's something else. There's something that goes on the Cartesian plane. So maybe we could say like, we'll call this dot over here. What's this dot sometimes called? Nasheen, is it not for functions? It's often used for functions, but in this section, we're really going to focus on what's called a coordinate pair or a point. And the way that we define a point is we have a number that comes first. So let's say 1, 2, 3, 1. Okay, I'm going to say this point is called 3, 3. And we talk about the X coordinate in the first position and the Y coordinate in the second position. And in this case, we're going to say we go 1, 2. In fact, let me make it a bit bigger. We go 1, 2, 3 across and 1, 2, 3 up. And that's how we get to that point. And we say the point 3, 3 is in quadrant number 1. Now, if I had to give you a point over here, often we give the points letter names. So we'll call this point A. Who wants to take a guess at the coordinates in point B? Just using the drawing we have here, what do you think the coordinate of the point B is? You can pop it in the chat and let me know what you think point B is using kind of the scale that we have here already. So we go 1, 2 across. Okay, let's go to Orotiwe. Orotiwe, what do you think B's coordinate's going to be?
Good evening, sir.
Hello.
How are you, sir?
Very good. And you?
I'm great, sir. I think it's going to be -3 and -3.
Okay. I mostly agree with you. And the scale's not perfect, but I think it only goes 2 across. So it is negative. And I agree it goes 3 up. But
Yes, sir.
So I think I'm going to make this -2
And
and then
-3.
it's going to be positive. It's not even -3. It's
Oh,
going to be
positive.
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 Yeah, because
Yes,
it
sir.
goes across by 2 and up by. Oh wait, I went too far across there.
It goes across by 2 and up by 3.
Yes, that's what I was trying to say. Thank you for the help. Fantastic. Okay, let's have another.
Sorry, Mr. Ears.
All good, all good. Let me draw another Cartesian plane. This one's getting a bit cluttered. So let's draw another one, and I'll try and draw it on the line so we can see. Okay, so I'm going to call this point C, and I'll make the point CXY. Can you tell me in the chat, what is the coordinate of this point C over here? And you can raise your hand and let me know the audio if you like, or you can put it in the chat. Both off. Perfect. Let's go to Resejo. Resejo, what is your hey?
I think the coordinates are going to be -2 and 3.
Aha. So I think the first one will be positive. So
Sorry.
I think there's a bit of an echo.
Oh, I think it's -2 and 3 and 2 or
I agree with the second. Let's have a look. No, I think so. It was close to what you had. I have +2, and then it will be -3 because I'm going across by 2, but in the positive direction, and down by 3. So we get -2, 3. But thank you. It was great to get your input in that process because we learned so much by going through each of these points. Okay, so 2, -3. All right, now let's do another one because this is an important skill. What about if I put my point here? I'm going to call this point D, and I want to know what is the coordinate of D over here. You have to be careful because there's negatives going one way and positives, and let's go to Kagotso. What do you think D is going to be?
I think D is going to be -3 and -1.
Okay, so I get your -3 from going 3 to the left, and then you go down by 1, which would make it -1. Fantastic. And I see Sino agrees, Feliciwa agrees, Somila agrees. That's awesome. Okay, so on our journey into analytical geometry or coordinate geometry, we have to understand what a point is. And a point is always written in the form XY, where the X is how much you go along the X-axis and the Y is how much you go along the Y-axis, or how much you go. This is, the X is across and the Y is up or down. Okay, now that's the first part. Then the second part that we need to talk about today is if we want to find the distance between 2 points. So say, for example, we wanted to find, in fact, let me go on to another, let's go on to a different thing for this. So I'm going to draw another Cartesian plane. And one of the skills we're going to practice today is how do we find the distance between a point like this and say, it's 2, 3, and a point like this. So I'm going to give A and B. I want everyone to write in the chat what they think the coordinates of A is and what the coordinate of B is. What do we think the coordinates of A are? What do we think the coordinates of B are? So I see Tabia said the point A is 1, 1. And so Sakile, and then what about B? What's B's coordinates going to be? So Leila is 1, 1. Yep. Mbali and Zanele. Letitia, let's go to you. What do you think B is going to be? Can you hear me, Letitia? Unmute you there. Okay, maybe we're having a few audio issues there, but no problem. I'm going to go 1, 2, 3, 4 across, 1, 2, 3, 4, 5. And I see most in the chat, I see 4, 5. Okay, so we really have mastered this coordinates thing. Now, the new skill that we need to learn is we need to learn how to find the distance between A and B. And we call this, we need to learn how to use something called the distance formula. But before we can do that, I want to ask you, if I had to ask you how long the red line was, could you tell me how long the red line is that I've just drawn on this thing here? And then I also want to know how long the blue line is. Time to bring out last year's books. Yes, so if we count the blocks, how long is the red line and how long is the blue line? I'm quite curious. I think the red is 3 units. Yeah. 1, 2, 3. How long is the blue one? So we count 1, 2, 3, 4 units. Okay. So I want to show you something interesting. If we focus on the x coordinate of B and we focus on the x coordinate of A, watch this sneaky thing. 4 minus 1 is 3. So this distance over here is just going to be the 4 minus 1, which is 3. And if we look at the y coordinates now, so the y coordinate was 5, and then the other y coordinate was 1, we can just go 5 minus 1 is 4. Get this one, because this was in line with a 5, and that was in line with a 1. Give me a thumbs up if you understand how I got the 3 by using the coordinates. I know everyone could see it visually, but do you understand how I subtracted the 2 x coordinates to get 3? Give me a thumbs up if you understand this part and this part. Okay. Awesome, awesome, awesome. Now, if this was a 3 and this was a 4, using another part of mathematics, is there a quick and easy way to find this using another part of mathematics if I tell you that this is a right angle? Can you think of, and Corsi, you were so quick. You didn't give any time. So quite right. If you have a right angle triangle, you can say the hypotenuse squared, or AB squared, because AB is the long bit, is equal to 3 squared plus 4 squared. And that's just because it's a right angle triangle. Now, that's what Pythagoras says, but I would really like to get the AB by itself. But the problem is the squared is getting in the way. Does anybody know what undoes squaring something? What's the inverse operation of squaring? The square root. Yeah. Fantastic. So if I square root this side and I square root that side, I'll get AB on this side. And then on this side, I'm going to get 9 plus 16. And then what is the length of AB going to be? It's going to be the square root of 25, which is 5. Okay, now, fantastic. Now, this idea is one that we can generalize in order to get the distance between any 2 points on the Cartesian plane. So, for example, the first thing I said is if I want a distance, so AB is a distance, I'm just going to say on the Cartesian plane, if I have 2 points, in order to find the distance between them with Pythagoras, I need a square root around the thing. Give me a thumbs up if you understand why there has to be a square root here and also in my formula. Because Pythagoras has all squares, and so to undo the squares, we need a square root. Okay, now, the next thing we need to do is we need to know the distance between the x coordinates. So what I'm going to do is I'm going to go x2 minus x1. So that's the distance. That was the 4 minus 1 part here. And I'm going to square it. And then for the second part, I'm going to go plus, and then I'm going to go y2 minus y1. I just took this away. And I'm going to square that. This is what we call the distance formula. And all it says is you need to find the difference between your x coordinates and square them. Then add the difference between your y coordinates and square them, and then square root them. So we need to practice this. So I'm going to give you 2 new points. I'm going to give you 2, 3, and b being 7, 9. Find me the distance between these 2 points, and you have to use this formula that I've just given you. What is your, so remember to do the parts. Remember, you must do those pieces. You know you're going to have a structure that looks a bit like that. So I'm going to go 7 minus 2 and if there are any questions, now is a great time to ask while you are pop your answer in the chat when you feel comfortable. So this is 5 squared plus 6 squared. So what that's 25 plus 36. It can be a decimal, yes, but you can just leave it like this. We'll just say it's the square root of 61. And so the square root of 61 is somewhere close to 8. So like 7 point something, something, something. Okay. 7.81 it seems. But I think it's probably better to, unless your teacher says make it a 2 decimal place, leave it as what we call a surd. So you should be getting the square root of 61. Okay. Now, that's using the distance formula. I think we need to have another round of practice, but I like what I'm seeing. So let me make, let me even clear some space over here. And let me pretend I know where the points are going. So let's say I want to know the distance between this point over here, C, and we'll say that, let me draw exactly on the line. We'll say that the coordinates of C, 1, 2, 3 across, 2 down. So -3 minus 2 is the coordinates of this. And let's say it goes to this one over here. And that's going to be that's going to be D. And that's going to be, the coordinates are going to be 2, 1. Can you try and find me the distance between C and D using the distance formula that we have just explored together? See if you can figure that out. We're basically trying to find this distance. And in a weird way, we kind of are, not weird way, we are using Pythagoras, but we're just using it in a very quick way. So let's see, C is -3, -2, and D was 2, 1. Oh, it's sorry, it's not 2, 1, it's 2 minus 1. Guys, can you see how I made a little bit of a boo-boo there? That should be 2 minus 1. My apologies. You can clearly see this D is below the y-axis. All right. And yeah, if there are any questions, please do raise your hand and I can assist. Or if you're unsure of something, how do we start this? Sometimes we say distance and sometimes we just say the length CD. So we go 2 minus -3. And then we can say -1 minus -2. So -1. Let me zoom in because it gets a bit. So then we should have 2 minus -3 is actually 2 plus 3. So 2 plus 3 squared plus -1 minus -2 is -1 plus 2 squared. Your calculator can sometimes help you do this more quickly, but it's good to understand. So 2 plus 3, that's 25, minus 1 plus 2, so that's 1 squared, that's going to be 1. You should get the square root of 26 units, which is just over 5. And so what we're saying is that this length over here is going to be square root 26. And the way we did that is we found that this distance over here was 5 and that this distance over here was 1, which makes sense when you think about it, because this point is 1 unit above it and this one is 5 units to the left. All right, give me a thumbs up if you're feeling okay with this so far. Give me a thumbs down if you feel unsure. I'd be interested to see how the class is feeling, just in terms of how many like how much repetition we should do. And do be honest, because we're all at different levels. I don't expect you. So Lutando, the reason I gave you one with negatives is I wanted you to see a different example where you have the negatives. So what's interesting is when you have the negatives, you notice that you need not only that but there, you also need that but there. And so that's why when it goes 2 minus -3, you get 5, because you need you need that minus or minus to get up to 5. When I put into the calculator, it gives us 5. I think you might have left off the 1 over here. Okay, we're going to carry on. We'll do one more example after the break, but I think it's good for us to have a quick little break. So don't worry if you're confused. We're going to carry on after the break. But first of all, we need to all stand on our feet, and we need to look somewhat like, well, we don't have to look as happy as that guy, but we can definitely stand up. So turn your cameras on and let's take a moment. Have a sip of water if you've got one nearby. And I want you to just loosen up forget you were doing maths and just swing those arms like you are, I don't know, a gymnast at the Olympics, whatever works for you. Do you know that the Olympics are coming up? No, 20, the Olympics come up next year. Oh, it's the Rugby World Cup that's this year. Next year's the Olympics. Okay, I get sidetracked. All right, so let's roll the arms back.
Please join in a stretch, guys.
Roll them forward. Okay, now let's twist the shoulders a bit. The other side. That feels good. Now let's do some small circles. Going into bigger circles. And then reverse it so it goes backwards. So small circles going backwards. And then big circles. Oh, lots of clicks. Okay, so hopefully your body's feeling a bit looser. Now what we're going to do is we're going to do a high heart rate activity. So we're going to do air skipping. So you pretend you have a skipping rope in your hands, and then every time it comes forward, you jump up. And we're going to do 25 of those. We're getting quite ambitious. Okay, 3, 2, 1. 1, 2, 3, 4, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, let's get to 30, 26, 27, 28, 29, 30. Okay, nicely done. Well done, everyone. I definitely feel like my heart rate raised a little bit. Not quite as bad as jumping jacks, if I'm honest. Jumping jacks still take the cake. And then I want us, for our little mathematical puzzle for today, to try and make 24 using these 4 numbers. So you have to use each number once, and you have to try and make 24 using these 4 numbers, using only the main operations, plus, minus, times, and divide, or brackets. Oh, I am a bit out of breath though. It's funny how this hits you. Your body's like, oh no, give me some more oxygen.
Yes.
I was getting a bit cocky there. And then my body was like, sit on down.
Oh, space.
Did I tell you I ran the 2 Oceans Half Marathon last week? It was,
Oh yes, how did that go?
Actually so fun. I would recommend it for anybody once you're old enough. It was such a big party. It was really great.
Oh, cool.
Okay, everyone. So 8 times 3 is 24, but you have to use all 4 numbers, but you're close. So you've used 2 numbers. How can you use the other ones and still stay on 24? What can you do? So I agree 8 times 3 is 24, but you have to use these 2. What can you do to sort of use them up? But Chuma, you're close. Think about what else you can do with 1. So Chuma is saying, I can go 8 minus 7 is 1. Now, if I add the 1 to 24, I get 25. But who can help Chuma? How else can we use the... so boom, gotcha. You're almost there. Yes. 8 minus 7 plus 1, not quite, Bomber. 24 times 1, yes. So if you go 8 times 3 times, and then you bring a bracket in and you go 8 minus 7, you'll just get 8 times 3 times 1, which is 24. And so that's what you do. You go 8 minus 7 to get 1, and then you use the 1 like that. Okay, so there are quite a few new students in the class today. This is just a game we play called Maths 24. And we try and make 24 using 4 numbers, but we have to use each number once, and we only use the main operations and brackets. So if you're new today, don't worry. It takes, we played this game many times, but I hope that it made sense to you. Sweet. Okay, I tell you what, I hope that you're feeling a little bit more unwound and ready for a second half of maths. Let's head back to what I was doing. So let's do one more distance formula question. Let's find what is the distance between, let's go 1, 2, 3, 4. 2, 3. So let's go down here up to up here, and we'll make this, this is -4 -3. So we'll make this E, and then this will be F, which will be -2 +2. Can you find me the distance between -4 -3 and F, which is -2 2? Show me what you got. I want to know what that distance is. You'll notice with the distance formula, we always have this predictable structure because we're always using Pythagoras. We're always basically working out the length of the one side, maybe like the green one, and then the length of the blue. Although we don't have to think of it like that everywhere. And then we get the red side, which is the final. So what do we have? We have -2. I like drawing lines. It helps me remember. So -2 minus -4. And then we have 2 minus -3. Move this down. What are we going to get for my final answer? We should get, it seems, the square root of 29. And so this bit over here, if we had to work out, this red bit would be the square root of 29, which since the square root of 25 is 5, and it must be, and the square root of 36 is 6, I'm guessing this is somewhere around 5.5. But we can just leave it in surd form, which is square root 29. Okay, I feel like obviously you need some more practice on distance formula, but you've got the main idea. And so I'm going to move on to the second part of tonight's lesson, but it's an easier part than this. But and it's called let's just do a quick vote. Thumbs up if you feel confident with the distance formula. Thumbs down if you feel unsure in any way about how the distance formula works. Define the distance between 2 points on the Cartesian plane. Quick little check. Okay. So this next one is so nice and easy. You're going to love it, ladies and gentlemen. So say we have a Cartesian plane and we don't want to find the distance between 2 points. We just want to find the midpoint between 2 points. So let's call this point over here point A, and it looks like it's going to be the coordinate 1, 1. And then we'll call the coordinate up here B, and this looks like 1, 2, 3, 4, 5, 6. So 6 across, 4, so 4 up. If instead of finding the distance between these 2 points, I want to find, we'll say the point M, which is in the middle, exactly halfway in the middle. It's another tool that we need to know how to find. And all we need to do, you really are going to love this. To find the midpoint M between A and B, all I need to do is add the first X coordinate, so X1 plus X2, and then divide them by 2. And then for the second coordinate, I take Y1 plus Y2 divided by 2. So how would that work in this particular context? I know roughly where it's going to be. It's going to be in the positive part of town, but I just go 1 plus 6 over 2 is the X coordinate of my midpoint. And then I go 1 plus 4 over 2 is the Y coordinate of my midpoint. And so what's that going to be? It's going to be 7 over 2 and 5 over 2. Or if I wrote it as not an improper fraction, but a normal number, I could also write it as 3.5, 2.5. And so this point over here, its coordinates are going to be 7 over 2 and 5 over 2. And we call this the midpoint of the line segment AB. Okay, so that's my idea. What I want to do is I want to give you a practice example. So let me give you another one, which is a bit different. Say I give you that point and I give you that point. And this is going to be the point 2, 2. And this 1, 2, 3, 4, 5, 6, 7. This is the point 4, 7. And I'll call this point C and this point D. I want you to work out for me what is the midpoint, I'll call the midpoint M, between C and D. And I want you to use the formula that I've just shown you, which is the midpoint formula over here. Give it a go, everyone. Give it a go. I'm leaving the old examples up just so you can see what's going, you can always use them as a kind of a helpful template. And if there are any questions, don't be afraid to raise your hand. I'm quite happy to assist everyone. So what do? We got 2 plus 4 over 2. That's the first bit. And then I go 2 plus 7 over 2, which gives me 6 over 2, which is 3. And the second one is going to be 9 over 2. So that's actually quite easy because you just add the two coordinates together and then divide. I do want to point out that instead of using the letter M, I'm actually now just saying the midpoint, so mid-PT, midpoint of CD. And that's often how we write it because otherwise there can be some confusion with the gradient. But that was really well done. Like what I'm seeing. Now let's do one where the negatives are involved, so it's a little bit harder. We'll make this point is going to be point E, and it's going to be 2 minus 3. So that's 2 minus 3. And then this point up here is going to be 1, 2, 3. So it's going to be minus 3, 2. We'll call that F. I want to know what is the midpoint between E and F. What is the midpoint between E and F? Basically between this, so this is the line segment EF. I want to know what is the midpoint between that. I'll say E is, go ahead and see if you can do that. So E is 2 minus 3 and F is minus 3, 2. Who would like to give me their answer for this one? Who's feeling like they were willing to share their thinking? How did they? No, let's go to Orikonisa. Can you hear me, Orikonisa?
Yes, sir.
What did you get?
I got -1/2 and -1/2.
Okay, so you got negative a half, negative a half. Let me see if I agree with you. It's looking good though. So is it a negative half? So 2 plus minus 3 is minus 1. Yep. Yep. I get minus a half, minus a half. And that makes sense because if you look at my drawing, can you see how it's sitting in quadrant 4? Like this, you can see it's just kind of snuck into quadrant 4 over here. And so even the visual interpretation makes sense to me. It makes me feel like, yes, I'm in the right place. So it's negative a half, negative a half. Oh, you guys are doing so well. Okay, so let's quickly summarize today's lesson. There's 2 formulas we've learned. The one was the distance formula, and the other one was the midpoint formula. The distance formula had a funky looking square root sign, and then it had 2 blocks of squares like this, and I went x2 minus x1 and y2 minus y1. And they were just basically lengths. The midpoint formula, I just had to take the 2 x coordinates, add them together and divide by 2 to get the new x coordinate. And then I did the same for the y coordinate. And so this is what we want to make sure we're comfortable with leaving today. Thumbs up if you feel like you understand both of these things quite well. Okay. So we've got about 5 minutes left. So let us then take our new understanding and let's check. Let's do some multiple choice questions. So let us do this first one. Is your answer going to be A, B, C, or D? What are the Cartesian coordinates of the point A in the drawing? Tell me what you think the answer is. Annie, if you accidentally swap, as long as you're consistent, it won't make a difference. But if you choose the one point to be your second point, make sure that it's the second point for both X and Y. Okay, so let's see what I think this is. I think it's in line with 4 over here and in line with 2 over here, which means the coordinates should be 4, 2. And which option is going to be the point 4, 2? It's going to be option B. Awesome. Okay, let's do another one like this. What are the Cartesian coordinates of the point C? Which of the options do you think is? Oh, there's quite a bit of variation, yes. So remember, everyone, we're looking at this point C. So X always comes first. So it feels to me like the -2 should come first. And then it should be in line with -3 on the y-axis. Okay. So we get -2, -3. Which option is -2, -3? It should be A. Cool. I like it. It's nice to have some fun recapping. Okay. In which quadrant do you find the point -3, 4? Is it in the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant? Remember, we did this at the beginning of this, and this is quadrant 1, this is 2, this is 3, this is 4. So which quadrant is -3, 4 going to be in? So I need to look at the X first. So if I'm starting here, I should be going 1, 2, 3 this way, and then up like that. Because it says -3, 4. So it goes across and up, which means I'm in quadrant 2, which means I go for option B. Okay. Now, at the beginning of the next lesson, what I'm going to do is I'll start with a little bit of revision of what we did today, but I think we're going to call it a day for today because I don't want to squeeze too much in. But Lebo, if you could put the poll up for students so that they can... So Tanda was asked, so if we put Y first, is the answer wrong? Yes. Very important question. So Tanda, the X always comes first and then the Y comes. And so that's why in this one, you had to go to the left first and then you had to go up. Okay, so that's a really important question. So while Lebo is putting the poll up, are there any final questions for today? Anything you want to kind of ask about? Otherwise, we'll start to finish off now. Pabalo, let's go to you.
Hello, sir.
Hey, how can I help?
So from what I've learned about the midpoint formula, we actually start with YC plus YB. Is it okay if it's like that, or do we have to follow according to what your understanding is?
Okay, when you have 2 points, so any 2 points, so let's just make some up, 2, 3, and 3, 4. All the midpoint formula says is you have to deal with the yellow ones first, so the X coordinates, so 2 plus 3, and then divide by 2 in order to get the X coordinate. Now, you could have, then you go to this one, and you go 3 plus 4 divided by 2. So you have to make sure that the X's go with the X.
Network.
Okay. So it is important that the X's go with the X's and the Y's go with the Y's. And X always comes first. So that's a very important idea. Yes, there's no negotiation on that. All right.
Okay, thank you, sir.
Cool. If you could just vote in our poll, everyone, we would very much appreciate it. So we have a good sense of how you found the lesson. It helps us keep our pacing in the right place, and it also just helps us. Are there any final questions? Okay, cool. Well, Kokotso, let's go to you. What is your question? It's not working. I think you just unmute, Kokotso. You need to unmute yourself. I think maybe it's...
Yes, sir.
Yes, hi.
Sir, can you hear me? Can you hear me? We say 2 plus 3 divided by 2.
Yeah.
What if we just did the whole equation and do not add the ones, the numerators?
Okay. If you only did the top, if you only added 2 and 3, then you wouldn't get the midpoint. It wouldn't give you the midpoint. And remember, the whole point, if you want to find the midpoint, it's an important thing for later on in the section. So if you didn't divide by 2, you wouldn't find the middle, is the important idea.
I mean, we just add all of it, including the denominator.
Okay. So if you went 2 plus 3 plus 2, is that what you're saying?
2 plus 3 divided by 2 and put it all together.
Oh, okay. So if you did that, you wouldn't have 2 separate coordinates. You need to have an X part and a Y part. So if you didn't have a gap between them, you wouldn't have an X and Y coordinate.
I mean, you add the whole X, the X part and the Y part separately. 2 plus 3 divided by 2 give you the answer. 3 plus 4 divided by 2 and it gives you the answer.
Oh, yes. Yeah, that's
Is it
fine.
possible to do that?
That's fine.
Oh.
Yeah, completely fine. Yeah. You can do it separately and then just put it together at the end. You get the same answer. Completely fine.
Okay.
Completely fine.
I just wanted to understand that.
No, absolutely. I understand exactly what you're asking. Thank you. That was good. All right, everyone.